Transformers? I've heard about them but never really understood how they work. Can you explain?
Sure. Transformers are a type of neural network architecture that rely on self-attention mechanisms to weigh the influence of different parts of the input data. Unlike RNNs, which process data sequentially, transformers process the entire input data at once, which allows for more parallelization and handling long sequences more efficiently.
That sounds promising. But how does the self-attention mechanism work?
Imagine you have a sentence, and for each word in the sentence, self-attention allows the model to look at other positions in the input sequence for clues that can help lead to a better understanding. The model computes a set of attention scores for each word, which determine how much focus to put on other parts of the input sequence when processing that particular word.
Okay, so it assigns relevance to different words in a sentence. How is this implemented in code?
In code, for each word, the transformer generates 3 vectors: the query, the key, and the value. These vectors are created by multiplying the embedding of each word by 3 weight matrices that are learned during training. Then, the attention scores are computed by taking the dot product of the query with all keys, followed by a softmax function to get the probabilities.
Could you provide a simple code example?
Absolutely. Here's a simplified version of how you might compute the self-attention in PyTorch. In this code, W_query, W_key, and W_value are the weight matrices that you would learn during training. Embedding_them is the size of the embeddings, and seq_length is the length of your sequence.
I see. So, the transformer uses these attention scores to give different importance to each word when predicting the next word in the sentence?
Exactly. And it's not just for predicting the next word, but for any task that requires understanding the sequence as a whole. This mechanism allows each word to contribute to the processing of every other word in the sequence.
This is fascinating. But I've also heard about something called multi-head attention. What's that?
Multi-head attention is an extension of the self-attention mechanism we just discussed. Instead of performing the attention mechanism once, the transformer does it multiple times in parallel. The independent attention outputs are then concatenated and linearly transformed into the expected dimension. This allows the model to capture different types of relationships in the data.
How does this parallelism help in practice?
It allows the model to focus on different positions of the input sequence differently. For instance, one attention head might focus on the syntax, another on semantics, and another on a specific part of speech.
That's quite powerful. How would I implement that?
You would extend the previous code to create multiple sets of W_query, W_key, and W_value matrices, one for each head, and then run the attention mechanism for each set in parallel. Finally, you'd concatenate the results and pass them through an additional linear layer. Here's a bit of what that would look like.
That does sound more complex, but also more capable. How do these transformers stack up in terms of performance?
They have been state-of-the-art for a variety of NLP tasks for a while now. They are the foundation of models like BERT, GPT, and others that have revolutionized the field.
It's clear I have some reading and coding to do. Thanks for the comprehensive rundown.
You're welcome. Don't hesitate to experiment with different configurations, and remember to have enough computational resources. Transformers are quite demanding in that regard.